Mechanical properties of materials. The mechanical properties of the metals are those which are associated with the ability of the material to resist mechanical forces and loads. The topic of the mechanical properties of material is of great industrial importance in the design of tools, machines, and structures. These properties are structure sensitive in the sense that they depend upon the crystal structure and its bonding forces. At the microstructural level, especially upon the nature and behavior of the imperfection which exist within the crystal itself or at the grain boundaries. In this article, we will discuss 13 main mechanical properties of the metals. These are strength, elasticity, plasticity, ductility, malleability, brittleness, stiffness, hardness, creep, fatigue, resilience, toughness, weldability. These properties can be well understood with help of stress-strain diagram given below. The stress-strain diagram is plotted with the help of tensile test, stress-strain curve. Now, we shall discuss the 13 different mechanical properties of materials. Strength. Strength is defined as the ability of a material to resist the externally applied load. The internal resistance offered by a material to externally applied forces is called stress. The capacity of resisting external loads by metal and to withstand destruction under the action of external loads against these stress is known as strength. The stronger the material, the greater the load it can withstand. This property of material therefore determine the ability to withstand stress without failure. Elasticity. Elasticity is defined as the property of a material to regain its original shape after removal of the externally applied load. We can take an example of a rubber band. Whenever we pull a rubber band, it gets elongated. That is, its shape gets deformed. But when we remove the load, the rubber band comes back to its original shape. Hence, we can say that a rubber band is an elastic material, or rubber band exhibit the property of elasticity. When the external forces are removed, it can also be referred to as the power of material to come back to its original position after deformation. It can be used as an important application of building precision instrument like spring or structure, etc. Plasticity. Plasticity is defined as the property of material under which the material is not able to regain its original shape even after the removal of the load. That is, the material permanently gets deformed. In other words, it is the ability or tendency of a material to undergo some degree of permanent deformation without its failure. Ductility. Ductility is termed as the property of a material that enable it to be drawn into the thin wire with the application of tensile load. The ductility is usually measured in terms of percentage elongation and percent reduction in the area, which are often used as empirical measures of ductility. In general, materials that possess more than 5% of elongation are called as ductile material. The ductile material commonly used in engineering practice in order of diminishing ductility, a mild steel, copper, aluminum, nickel, zinc, tin, and lead. Malleability. Malleability is the ability of the material which enable it to be flattened into thin sheet under application of heavy compressive forces without cracking by hot or cold working, which means it's a special case of ductility which permits material to be rolled or hammered into thin sheets. A malleable material should be plastic, but it is not essential to be so strong. The malleable materials commonly used in engineering practice in order of diminishing value, wrought iron, copper, and aluminum, lead steel, etc., are recognized as highly malleable metals.